Imagine a world where everything is uncertain. You look at an atom, but you don't know where it is or where it's going. Think of a soap bubble floating in the air. You know it's there, but if you try to touch it, it might pop or change direction. This is the kind of uncertainty that governs the world of atoms. That world exists, and it was Werner Heisenberg who revealed it to us. Get ready to discover the story of the scientist who taught us to see the universe differently. Did you know that Heisenberg developed his revolutionary ideas while isolated on a remote island? His life is full of surprising moments like this. This is the story of Heisenberg, the master of uncertainty, whose work paved the way for technologies like quantum computers and transformed our understanding of the universe. But before we embark on this journey, please like, subscribe, and share it with your friends. Born on December 5th, 1901, in Würzburg, Germany, Werner Karl Heisenberg grew up in a household that valued intellectual rigor and scholarly pursuits. His father, August Heisenberg, was a professor of medieval and modern Greek philology, while his mother, Annie Wecklein, belonged to a family with a strong educational background. This cultivated environment instilled in young Werner a love for knowledge and an early curiosity about the natural world. Even as a child, Heisenberg displayed a remarkable aptitude for mathematics and problem-solving. While his peers engaged in ordinary pastimes, Werner immersed himself in puzzles, equations, and logic. By the time he entered the Maximilians Gymnasium in Munich, it was clear that he was academically gifted. He excelled in mathematics and physics, standing out among his classmates and earning recognition from his teachers. The political and economic instability that followed World War I left an indelible mark on Heisenberg's youth. Germany was undergoing a period of uncertainty and upheaval, and the war's aftermath shaped his outlook on life. He briefly engaged in political activism through a youth group, but soon realized that his true passion lay in the pursuit of science. This realization propelled him toward a path that would redefine modern physics. As Heisenberg's education progressed, his love for theoretical physics became apparent. Encouraged by his academic mentors, he sought deeper knowledge of the natural world's fundamental principles. In 1920, Heisenberg enrolled at the University of Munich. Eager to explore the frontiers of physics under the mentorship of Arnold Sommerfeld, a distinguished physicist known for his contributions to atomic theory. Sommerfeld's approach to physics emphasized mathematical precision and creative problem-solving, which resonated deeply with Heisenberg. During his university years, Heisenberg's reputation as a brilliant student quickly grew. His ability to grasp complex theoretical concepts and his relentless curiosity set him apart. His academic journey took a significant turn in 1922 when he attended a lecture by Max Born at the University of Göttingen. Born's introduction to quantum mechanics captivated Heisenberg and set him on a course toward one of the most revolutionary scientific fields. By 1923, Heisenberg had earned his doctorate under Sommerfeld's supervision. His dissertation focused on turbulence in fluid dynamics, demonstrating his ability to apply mathematical rigor to complex physical systems. However, his primary interest lay in the mysteries of quantum mechanics, and he soon received an invitation to work with Niels Bohr in Copenhagen, a decision that would change the trajectory of his career. Arriving at Bohr's Institute of Theoretical Physics in Copenhagen, Heisenberg immersed himself in the development of quantum mechanics. Bohr's mentorship and the intellectually stimulating environment pushed him to challenge traditional scientific paradigms. It was here that Heisenberg formulated matrix mechanics, the first formal structure of quantum mechanics, which relied on mathematical matrices rather than classical concepts of motion. The breakthrough came in 1927 when Heisenberg proposed the uncertainty principle, a fundamental tenet of quantum mechanics, stating that the position and momentum of a particle cannot be simultaneously determined with absolute precision. This principle shattered classical notions of determinism and introduced a probabilistic understanding of the atomic world. His discovery was met with both acclaim and controversy. Many physicists, including Albert Einstein, struggled to accept the inherent randomness of quantum mechanics. Einstein famously criticized Heisenberg's idea, arguing that God does not play dice with the universe. Nevertheless, Heisenberg's work became the foundation for the Copenhagen interpretation, developed alongside Bohr, which remains one of the most widely accepted interpretations of quantum mechanics. Despite the controversies, Heisenberg's contributions were widely recognized. In 1932, he was awarded the Nobel Prize in Physics for his pivotal role in the development of quantum mechanics. This honor cemented his status as one of the most brilliant physicists of his generation. Heisenberg's uncertainty principle sent shockwaves through the physics community, challenging classical determinism and redefining the limits of scientific measurement. His ideas sparked heated debates among the greatest minds of the era, particularly with Einstein, whose resistance to quantum indeterminacy fueled some of the most famous intellectual exchanges in modern physics. However, the rise of the Nazi regime in Germany created new challenges for Heisenberg. His association with modern physics, which some Nazi officials viewed as Jewish science, led to political attacks. Heisenberg found himself caught in ideological conflicts, defending his work while navigating the increasingly dangerous political climate. As the world edged closer to World War II, Heisenberg faced moral and professional dilemmas that would define the next chapter of his life. His involvement in the German atomic program during the war remains one of the most contentious aspects of his legacy, raising profound questions about the responsibilities of scientists in times of conflict. As war engulfed Europe, Heisenberg was appointed as one of the leading figures in Germany's nuclear research program. Tasked with exploring the feasibility of nuclear energy and weaponry, he found himself in a morally complex situation. Unlike the Allied Manhattan Project, the German effort never resulted in a functional bomb, leading to questions about Heisenberg's intentions and possible acts of resistance. At the infamous 1941 meeting in Copenhagen, Heisenberg met with Niels Bohr, leading to decades of speculation about their conversation. Did Heisenberg warn Bohr about Germany's nuclear ambitions? Did he deliberately hinder the German bomb project? These questions continue to spark debate among historians and physicists. After Germany's surrender in 1945, Heisenberg and other prominent German scientists were detained by the Allies and taken to Farm Hall in England. Their conversations were secretly recorded, revealing their shock upon learning about the atomic bombings of Hiroshima and Nagasaki. The transcripts suggest Heisenberg had misunderstood key aspects of nuclear chain reactions, though some believe he deliberately avoided building a bomb for Hitler. Following his release, Heisenberg worked to rebuild German scientific institutions. He played a crucial role in the establishment of the Max Planck Institute for Physics and advocated for peaceful applications of nuclear technology. He sought to distance himself from his wartime associations and refocus on theoretical physics. In his later years, Heisenberg turned to philosophical inquiries about science and reality. He explored the implications of quantum mechanics beyond physics, delving into metaphysics and the philosophy of science. His final years were spent reflecting on the intersection of science, ethics, and human responsibility. Heisenberg's contributions to physics continue to shape modern science. His uncertainty principle remains foundational in quantum mechanics, with applications in fields from computing to engineering. His role in wartime Germany remains debated, but his scientific achievements are undisputed. Heisenberg's work illustrates the profound impact of scientific discoveries on society. His story highlights the ethical dilemmas faced by scientists and the enduring quest to understand the universe. His legacy is a testament to the power and responsibility of scientific inquiry. Werner Heisenberg taught us that we don't need to know everything with absolute precision to understand the world. He showed that uncertainty can be the path to knowledge, and that is why he is one of the most important scientists in history. And now, whenever you hear the word uncertainty, remember Werner Heisenberg, the man who saw order in chaos and taught us to look at the universe in a different way.